When you pour salt on a rectangular piece of cardboard that's been lifted up on a pedestal, something interesting happens. It doesn't just form a lump. When you look at it in the right light, you see that it's formed something very organized, like a pyramid thingy with clean, sharp edges.
Whoa.
Then you start thinking, I wonder why, and I wonder what properties they have. And then you realize, wait, when you look at these edges from above, it looks like these are the angle bisectors of the rectangle's angles. Which then makes sense, because if you imagine dropping a grain of salt somewhere around there, it's equally likely to go this direction or that direction. It forms a symmetry. So we've got 4 angle bisectors, each bisecting a pair of sides in the rectangle. And what about this middle segment, that top ridge? At first, it seems like this is something different. Where the other 4 segments seem to be angle bisectors, this one seems to be something called the locus of points equidistant from 2 parallel lines. And that's kind of satisfying because after all we did was pour salt on a rectangle, and instead of forming a lump, it formed 5 ridges, 4 of which are angle bisectors, and 1 which is the locus of points equidistant from a set of parallel lines. But then it hits you. Imagine 2 lines that are hinged to the plane at 2 points, like these straws. This dotted line represents their angle bisector. If I rotate these straws in opposite directions the same amount, the intersection point moves up, but the position of the angle bisector doesn't move. If I keep doing it, that intersection point keeps going up, 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 all the way to infinity, and then in an instant, the point of intersection appears way down at negative infinity and begins racing up until it comes into view again at the bottom of the screen. All this time, the position of the angle bisector didn't move. It never stopped being the angle bisector. But remember, there was that instant where the lines were parallel, where there was no point of intersection. But there that dotted line still was. And you realize that the locus of points equidistant from 2 parallel lines is really just the angle bisector of 2 lines whose point of intersection doesn't exist. They're all angle bisectors.